Hi guys, welcome back. So we are in functions, and till this inner functions we have completed, correct? Now let's move on to the next one. Let's talk about this variable scoping, global variables, local variables. Fine, let's talk about them. So whenever you declare a variable outside a function, we call this as global variable. Whenever you declare a function inside a variable inside a function, we call that as a local variable. So you could see here. Fine. Local variables declared inside a function. What is declared outside is called as a global variable. Already we saw that, right? So accessibility rules apply there. Global variables are available in all the functions. Local variables are available only within the function. That we already know. Okay. What we don't know is we have some more information with regard to this. Okay. Now, when we are working on this, we will definitely have different needs. Now let's talk about those different needs. For example, let's say I have a num at global level. Now I have a method which access it. So you can very well access that, correct? So here if I'm going to call this met, now you can very well access that particular find 100. Okay. Can I change that value? Let's try that out also. Num equal to find 200. And now if I'm going to run this, absolutely it gets changed. Correct or not? Absolutely it gets changed. So if I say num equal to 200, fine, it has come here. But what I would like to understand here is, now what is the value of num? Is it 100 or 200? Print num. See, it should have become 200, right? Now let's call this, but still it's 100. Why? So when you are declaring a variable inside a function, remember it has created a new variable by name num, and it overrides the global variable within this function. It is actually not pointing to this, whereas this num is pointing to this. If I give a different name, then the num this will print still num as 100. So that is not an issue. But if I give same name num equal to 100 or num equal to 200, what will happen is the local variable will have more precedence over the global variable. So actually speaking, you are not changing the global value, you are declaring a new variable, and that is what is printing. Getting it? Okay, now the requirement starts. How about me accessing this? Now one of the option is you can very well have a different name. If you have a different name, you don't need to worry, num will be still 100 and it will be pointing to that. But many cases you may not be interested in having a new uh, variable. You would like to change the global variable itself. You would like to change the global variable itself. Now in that case, how do you achieve this? There are two ways by which you can achieve this. One is using a keyword called global, another is using a function called globals. Now, first, let's check it out, this globals function. Now, what you have to do is you got to say n equal to, I'm saying n equal to globals. Now, what is this n, sir? Now, what is this globals going to return? Globals will return all the global variables. Now, if I want, I can give like this. Global num equal to, I can say n of num. So it basically returns a dictionary of global variables. Now with the help of that name, you can very well access it. Now you can say global num equal to 200, and here I can print global num. Apart from this, the num is also there. Now in this case, now you will get here 200, here also 200, because you are changing global num variable. Please look at it. I'm sorry, because you are having this, but this is a new variable, right? So I'm sorry. So what you have to do here, you will get 200. In case if you want that value to get changed, then you should say n equal to 200. Okay, and then you can very well print that n of num. Am I right? Now it will be. You don't give this global num. Fine. So this will be a new variable again. Correct or not? So now let's run this 200. Correct. So basically, what is that we have done? We have accessed the global variables by using this globals function. By using these globals, you actually get the global variables. Now you can it returns a dictionary of global variables. Now you can use the key and read that. Fine. This becomes a local variable. You do make changes, it will be only in the. But if I'm going to access that dictionary, it is basically referring n of num is referring to this. So if you make a change, the change will get reflected in the global variable. Got it, guys. So this is one way. Globals keyword is one way by which you can refer the global variable. You can make changes to the global variable, and the changes will be reflected outside the function. Got it. This is one way. So what is the other way? The other way is you have a keyword called as global. Here it's not a keyword. This is a function, correct or not? This is a function. Whereas you also have a keyword called global. Now you can also use the globals and then achieve this. So how do you do that? Let me take this out. Fine. Now, in case if I want to access this global, what should I do? Very simple. You have to declare global num as global first. You have to declare num as global. Now you can say num equal to 200. Okay. Now print num. So here it will print 200, and here also you should print 200 because you have declared this num as global. Now look at this. Now this looks more easier, right, than the previous one. Again, it has everything has a own, no, I mean scenarios. Use it appropriately. But remember, there are conditions when you are using global num. See, you this num I'm saying it refers to global. But if I'm going to declare this num as global, that num shouldn't have been used earlier. For example, I could not even say print num before using num or before declaring num as global. Num is used prior to global declaration. So this should be the first line inside the function, or this should be written before the usage of that particular variable. So number one. Okay. So this is one thing, and one more thing is when you are declaring a variable as global, you also get an advantage. You can also say num equal to num plus 200. Now these things are possible only when you say global. Only when you say global. See, if I don't give global, see immediately to throw an error. It will, in that case, what you should do is first you should say num equal to something, and then only you should use. Whereas you are working on the global variable, so num equal to num plus 200 fine will not work until you declare this as global. Please understand. So only global keyword will allow us to use this variable which is outside the function. If I don't declare it global, I cannot use it outside the function. I cannot refer a variable which is outside the function. See here, now it will be 300. So this is another way by which you can access this. Got it. So globals, one method by which you can access the global variables. variables. Another is global, a keyword by which you can make the local variable point to the global variable. Cool. Okay. There is also one more thing called as non-local. There is also one more thing called as a non-local. What is non-local? Non-local is primarily defining almost same thing. See, local, global, only two things we have, right? So what is the opposite of local? Is global. You can also refer that as non-local. Non-local is synonym to global. Then why do we have a separate word called as non-local? This is needed because when you are working with inner functions, outer inner functions, there we need to make use of this keyword called non-local. So in a normal scenarios, you make use of the keyword global, but in a function, inner function and outer function, we use the keyword non-local. Shall we understand this? So here I am saying def outer and def inner. So in the outer, I am declaring a variable. Here I am saying num. So here I am calling inner outer. So you know very well, before outer I can call, because the num belongs to outer. So let's run this. Okay. Now what I do is I try to do the same thing what I did with num previously. If I say num equal to 200, fine, and then print, this will be 200. What will be this value? Check this out. That means it is not referring to the global one. So how do you refer this to the global one? Shall we try this out? So here we can say global, let's say num. If I do so, let's see what happens. It is not having any impact, right? Is it having any impact? So this should be 200, correct or not? Because I've changed, but it is still printing 100. So what I do is instead of this, I say non-local num. So when I say non-local num, then this belongs to this. That's what it means. Now let's run this. Got it. So in an inner function and outer function, clearly understand the difference, guys. Where do you use global? Where do you use non-local? Non-local is used in only in inner functions, whereas global is used in normal sets. I'm sorry. So global is used in normal functions, whereas non-local is used when you are having it as a inner function. See here, global is not working. See if I remove this and use global, see, this is not working. Correct on. It's not working at all. Am I right? So if I have to definitely use non-local. Got it? Is that clear? So that's what I have in the next slide, non-local, which will work in inner functions. So a direct, final glance on local and non-local, all these things. So when you are declaring a function, the global variables can be accessed within the methods, but you cannot make any change to the global variable. If you want to make a change or if you want to access the global variable in a normal thing, then you can use either global's function, get it as a dictionary and process it, or global keyword can be used. Non-local can be used when you are going to have a inner function. Fine. Inner function, inner functions may when you're when you're accessing the variables of outer functions, then you have to make use of non-local. Got it? Is that clear? So that is with respect to your scoping of variables. புரியுதா? Okay. Now let's talk about the next thing, recursion. Now recursion is a beautiful concept in functions, predominantly used. In fact, many mathematical programs are written using a recursion. Now, what is recursion? Recursion is a function calling itself. A function calling its own function is what we call as recursion. Repeatedly, it will call. And every programming language supports this. And how it works is more interesting, basically. So, when a function call itself, now please understand, function will have lot of state and lot of execution. Now, if it has some pending state and pending execution, those things will be stored in a stack and then they will get executed after the recursion completes. So, which means the recursion has to complete, it has to have an end. It should not be infinite. If it goes infinite, then you will get a memory overflow error. Now, that is also called as a, I mean, it's also referred as a drawback. So if you don't have a proper condition to stop recursion, then you will get runtime error which cannot be handled at all. You cannot handle that. Program will crash. Another one problem with recursion is since it creates a stack, so memory will get used, and because of which recursions may give some performance problem or it may have a little delay in performance when working. That is also there. One more biggest drawback of recursion is when you are working on recursion, when of course computer does something internally, if you want to debug that, debugging is going to be next to impossible as far as the recursion is concerned, because internally what stack it creates, how it works, how it generates the values, fine, that is basically the language driven, and if you are trying to debug that, it's going to be a nightmarish. So these are referred as general problems, but the advantage is mathematical problems can be solved fine with the help of recursion. Several, like for example, factorial. If you want to calculate, recursion is the best way to do it. Getting that. So let's see how a recursion works primarily. So let me have an method def fine met, and here I would like to have an check if n is lesser than 10, and here I'm going to increase n equal to n plus 1. But if I have to do this n equal to n plus 1, what should I do? I should say global n. Correct or not, guys? If I don't give a global n, then it will not know who which n to access. Correct? So global variable I have to access means I have to declare n as global. Now I'm going to say this, I would like to keep it outside, and here I'm going to check global n, and then I'm going to, if n is lesser than 10, I would like to call the method again. Okay, how this works? Now until n is lesser than 10, the met will be called. Now let's say I have one print here. Now the question is when it will get printed, how many times it will get printed, and what will be the n value. See, you can understand recursion very easily now. Now, when I'm going to run this, this function will run 10 times. Met will run 10 times. And at the end of the 10th time, the n value will be 10. Okay. Now, every time it runs, it has some balance statements, right? The met function totally has 5 lines, but only 4 lines. Fourth line, may it calls met again, met again, met again. So, what happens to the remaining lines in the program? The remaining lines of the program will enter into a stack, and they will get executed once the recursion is completed. Line by line, they will get executed. One by one, they will get executed, and you will get print the 10 called 10 times, because 10 times the method runs. See this? And every time the n value will be 10, because the last state of n is 10. So that's how it works. See this? let's say what's the problem. I'm calling met here. Fine. Print n, correct. Okay, I'm not calling the method itself. Start should be there, right? Correct or not? If I don't call the met, then it will not start. So now let me run this. Wow. So see 10 10 10. See, every time it comes, if I am going to have this print n here, but the most interesting thing is if I keep it here, right? Now, how exactly this works? See, the example I can give you for this is, let's assume that a person is having food. When he's having food, he gets a call. He does not answer that. He remembers it. Then he again gets a call. He again gets a call. Let's say three calls he got. He didn't answer. Now, after he completes the food, fine. Now he calls up the first person, fine, who called him. Then he will answer the questions of him. Let's say he asked the question, how about food? Will he say eating or he has finished eating? So obviously he will say finished eating. So that's what's coming. 10, not 2, 3, 4. So when he gets call, he remembers that in a stack, keeps that in pending. So after he completes eating, he returns the call 1, 2, 3, and this time the state of the particular object would have also got changed. And when he returns the call, he will give that current state, and that's what is happening. The current state is 10. It is printing, and how many times it has to print? 10 times, because the method is called 10 times. As simple as that. Got it, guys? Is that clear? Okay. Based on this, let's also do one factorial exercise so to see how this particular thing works. Factorial is basically you can give a number. For example, let's say if you give number 4, then it will be 4 into 3 into 2 into 1 is the factorial of that. So it will come as 24. If it is 5, 5 into 4 into 3 into 2 into 1, which will be 120. So like that, you can also find factorial for any number. So if I have to do a factorial exercise with this recursion technique, then how do I do this? Now, see here, I'm saying factorial. This is a famous question you will get in most of the exams. So factorial of x, and here, first of all, if x is equal to 1, then I'll return 1, because the factorial of 1 is 1. Okay, else the real thing starts. Now what I can do is I can say return x into factorial of x minus 1. That's it. Now you can say n equal to, fine, factorial of 4 print n. So every time I call the factorial, fine, it ensures that the x value is reduced. So once it reaches x1, then it returns the this condition will get satisfied, and the uh, termination happens for the recursion. See here, I get it. If I say 5, sorry, here if I say 5, then the value will be 120. How exactly this works? So primarily what it is doing is, it is having that factorial called, and x that time is basically, fine, 5, and into that is 4. So that statement is put in a stack. That statement is put in a stack, and then the next value will be uh, 5 minus 1 4, then 4 minus 1 3, then 3 minus 1 2, 2 minus 1 1. So every time it works like this: 5 into 4, 5 into 3 into 2 into 1. That's it. So that way you get a value of 120 at the end of that. Getting this, guys? So please understand this. very important for us. In case if you feel like you want to debug this program and see, I already told you it's not possible to actually debug and see how it works, but PyCharm has a facility to debug. Let's also see this program in debug mode, and let's see whether we can understand anything. If you want to debug this program, just press in the left hand column, this red ball icon will come. Okay, and now you can very well run this. You could see here one debug icon, and triangle is the debug. Now run this, you will get a different window, and here this green symbol indicates resume, so you can click on this and you can see how it goes. See, right now x is 5, so a little bit of debugging is what we can do here, but normal programs may it will be very good, this debugging mode. For factorial, very less, no, I mean, help. Now inside the function it has come, so now return x into factorial. So right now x is 5, 5 into 5 minus 1, 4. So now x has become 4. Okay, so here it goes. Makes sense little bit. Okay, now let me stop this. You also have one more. Let us also do like this. Let me say n equal to, okay, and then let me return this in, so that just to for debugging mode, I want to know, check this out like this. So let me have this also, no, debugging mode, and here let me run and see what is it. So first factorial, so it has come here, x is 5, fine. So it has come x equal to 1 is not satisfied. Now it has come here. So x is no 4 now. But what happened to n? Why n is not displayed? That is put in the stack. That is put in the stack. Now let me run this. X has become now 3, fine, 2, 1. Now let's see here. Now the stack is going to run. Now n is 2. Stack means last in first out. So from the top it gets no multiplied. It's from the last side. 2 into 3 into 4 into 5. That's how it goes basically. Getting that. So n has become 2. So one by one it will get executed. Then n has become 6, because 2 into 3, 6. Then it will be like that. It will go. Getting that. The last 120 will come. Cool. Is that clear? So this is, you are learning debugging mode, as well as you have learned how recursion works with respect to factorial. Got it, guys? Is that clear? Fine. So let me also finish off these Python modules in this very small thing. Python modules already we have seen. That is what we called as constant. One file we created, right? In constant may we used modules. Now let's also see modules here one more time. So you know very well, modules are basically the extra files which you can import in your programs. Already you have seen this myconstant.py, right? So if you want, you can have variables. You can also have methods here, and if you want, you can access them. How do you access them? You can say import, then you can say mycons file, and then you can very well say print mycons dot. So this is how you do import. This is how you do import. Correct or not? Not only that, you can also say mycons dot met. Methods also can be called, and you have the method also declared here. Correct? Okay. Apart from this, in this import also you got some, facilities. For instance, we also have import called a static import. A import where you don't need to give this mycons every time. So from mycons import star, this is also another way. If you do like this, then what will happen is you don't need to give this mycons all the time. You can just like that give like this, and you can use. Remember this. This is called a static input. Even in Java language, we have this kind of facility. Fine. Other languages also have this kind of facility. So that no, you don't need to repeat that micons again and again, again and again, again and again. Getting this, guys. So this is also one more way. Okay, apart from your own this thing, if you want, you can also import Java. Sorry, Python has many modules. Like for example, you have got a math module, random module, and all. Let's see math module, which is there, like by default. Like if you want, you can also import math, and believe me, math also has a variable pi. Apart from this, it has so many methods also. Find so many methods also. Like for example, see math pi is there, then sin h is there. Find print sin, find 30. So sin 30 it will print. Getting that. So math is a very super duper one library. You can make use of that. We call the library or module, you can make use of this. Apart from this, you also have a library called as random. See, both two three, any n number of things you can, n number of uh, modules you can import. I've imported now random. See, you got so many methods. Like see, you can say rand range 10 20. Fine. Let's rand range, fine, of 10 comma 20. Let's see what it prints. Let me run this again. See, it is picking up randomly a number between 10 and 20. Correct or not? We call this as seed value. We call this as seed value. Apart from this, we also have some more methods. Print, find random. Now this returns a decimal value, basically based on Gaussian theorem. We also call this theorem as Bell theorem. So any number between 0 and 1 with, I mean, the precise decimals it will give. See, if you want this to be a whole number, then you can very well multiply this with 10 or 100. You'll get a whole number. Cool. So this is basically, as I said, Gaussian theorem or Bell theorem. They'll create this random. Now look out for the other thing. Shuffle is there, choice is there. Please have a look at it. Fancy. I'm showing you a few things, right? The rest of the things you experiment. Then only we both can have things better. Okay, guys. Okay. Last but not least, when you also have this we have seen, you also have something called as packages. Now, packages are basically to structure things. Like rather than having this mycons.py in the direct directory, you can also create a directory under Danish. Like for example, say I have created a directory by name mypack. And within that mypack, how do I create? Right click on this, say new, I can create a directory. If I do so, I can give any name, my pack to something like this. And inside that also I can create a file, a, a Python file. Fine. What happens? Not creating. Right? Sometimes no. I don't know, something wrong. You should be able to create. I have created here. See, I have created here. It is very much. Let me create one more. Yeah, it's coming right. Now, why my pack 2 may you're having this problem? My pack 3 that has gone outside, right? My mod import, let's say my pack 3 dot fetch my mod, sorry, it is okay. So here I have created a package directory, and within that also you can, and here I can very well say print my mod, sorry, my pack 3 dot my mod dot py. So looks cool. Can I have this with the from option, from my pack 3 dot my mod import star? In that case, I don't need to specify this lengthy name, right? I can straight away do like this. Got it, guys? So packaging is a way by which you can have the things properly placed in directories, and then you can use. So that is more better, correct or not? Rather than having everything in one directory and no getting confused, you can arrange them properly. So that arrangement you can do it with packages. Okay, so that's all we have with respect to functions, guys. Hope you would have understood. We have seen elaborately the different things in functions. Fine, appreciate if you could go through that and know, I mean, repeatedly several times and understand this, comfortably. Make sure you are clearly understand this. It's very engaged. You if you could understand, and definitely you will remember this for life. Okay, thank you very much. And the next we are going to talk about the part 2. So part 1 we are completing here. Part 2 we are going to start. Thank you.